Welcome to Engage 2021. I hope you're enjoying the conference where you can connect with others, learn from wind shuttle experts, and collaborate and discuss industry best practices. I'm here today to discuss how security builds trust in frictionless commerce. Frictionless commerce is where you're lowering transaction costs and increasing the convenience and ease for people shopping online. Frictionless retail implies much more though, making the web shopping experience easier, facilitating data collection from consumers, and using digital connectivity to help squeeze the friction out of entire systems. Security has a large practice in that. Hello, I'm Todd Edwards. I'm the Senior Director for Cybersecurity for Pivotree. I've been in the industry for over 20 years, architecting, designing, managing, and leading large security and technology business solutions for retail, healthcare, and government online services. Let's start with talking about trends in 2020. 2020 was the COVID year, and it increased online shopping by 40% in the first 8 weeks alone. This was because stores were closing and everybody was shopping online. This actually made it so that the holiday season during 2020, there was a 10 times increase in cybersecurity attacks. This hit a number of major brands, including Microsoft, Estee Lauder, Virgin Media, Nintendo, Claire's, and a number of other companies. Microsoft saw 250 million Microsoft customer records spanning 14 years of data discovered online without password protection because of misconfigured servers. For MGM Resorts, the personal information for more than 10.6 million guests who stayed at the MGM Resorts were leaked on a hacking forum. Claire's, the jewelry and accessories retailer, were informed that hackers using megacart tactics stole their customers' payment card data. The current climate for 2021 is a bit of a surprise as well. We've had the largest DDoS attack in recorded history. We've had tens of thousands of websites down in one day. We've had Poly networks hacked for over $6 million in cryptocurrency. Every day we're finding newer and newer attacks coming in, and companies are paying out millions and millions of dollars in cryptocurrency and having to apologize to their customers. All that activity in 2021 has led to the top 3 risks. Internal threats are when hackers actually hire people inside the company to give access, or through social engineering find out who the important people that have access to get information inside the company, or through third-party compromises, which are vendors that have vulnerabilities in their software, or hackers gain access to them and then gain access to company systems indirectly through the integration points, APIs, etc. The third being ransomware breaches are conducted in different ways. Hackers usually get access to systems and stay there, playing around or wandering throughout the system, gathering information about the company before the encryption is done. It's very rarely that encryption happens immediately. When the encryption is immediate, it's usually because they've tailored to a specific vulnerability in specific software to gain access right away, launch it, and leave. Usually there's compromised security on access or through APIs or software where they can wander the system for a while, learning about the system and then tailoring the ransomware to that system specifically. Those are the ones that really need to be monitored. This is not to discount any of the other risks that we find in cybersecurity today. By addressing the identity and access management of third parties and internal systems, we can make it difficult for hackers to get in, for hackers to compromise the systems. And hackers, when they're bored or when they have a difficult time getting in, usually go elsewhere. To mitigate those risks, we need priorities for 2021. The first of those priorities is to build a zero trust framework. A zero trust framework removes the idea of trust, meaning you don't assume that by having access to a system, that the people accessing the system, the roles that they're given, and the activities that they're doing can be trusted. Ideally, we hope to have trust in all those systems, but by tracking and monitoring, we can see that the activities are normal, and then tag and find the abnormal activities that happen when there are breaches. This is because people breaching those systems are actually using the access of others. So if you see that normal activity by a CEO, a CFO, or even an administrator are to do certain things and certain activities throughout day-to-day activities, you can see when something strange happens or something unexpected, or they're accessing something that they normally don't. This makes it so you can identify that the trust has been broken. This means you can use the data to do behavioral analytics and know that alerts can be generated if activities are other than normal on any day-to-day activity used by any of the people within the corporation, the suppliers that are accessing your systems, or even your customers themselves. The second priority is threat intelligence, or in our case, cyber threat intelligence. It is information an organization uses to understand the threats that they have or will have on their current organization. This information is used to prepare, prevent, and identify cyber threats, but they're usually outside feeds coming from government organizations and large security organizations that have been tracking the malware, threats, viruses, and other ways that people have been compromised. This is very useful by sharing this information between companies, especially companies of the same industry. They can see that the patterns are the same, and it means that they can put the reverse of those threats into action early on before the threat ever comes. This is very helpful when it comes to reporting on the threats. The third priority is supply chain risks. Risk management for suppliers is the process in which businesses take strategic steps to identify, access, and mitigate risks to end-to-end supply chain. This is where internal and external communication happens through the partners, vendors, the suppliers, and the delivery of any product to a customer. By actually putting together a risk mitigation plan for each of those components, you now have a safe way for customers to access your e-commerce sites, for suppliers to deliver product to those customers, and for you to get the financial transactions expected. So after all the bad news of 2020 and all the scary news of 2021, how is it that security can become frictionless? The key to security becoming frictionless is that by identifying early on in the creation of a product, an e-commerce site, or even just reinventing the sites that already exist, identifying this security throughout the process of product development makes it so that security no longer becomes an afterthought, something that you need to put into place after you've launched a product to make sure that it can be put into production without any incidents. By introducing security in the 5 stages of product or business development, you're able to identify the security components needed and tracked throughout so that you can create a lifecycle management of that product and always keeping it secure, not looking at security after the fact or during the stages. A good example of this is by identifying right from the beginning of your business strategy when wanting to launch an e-commerce site, what are the crown jewels? In other words, what are we trying to protect? Not just the business, but the customers, the transactions, the systems, and the data. Clearly identifying a plan on how the business objectives align with security of those business objectives, even at a high level in the beginning, creates a guideline for operational people to link back to whenever they have questions against the security that they find or the lack of. Once you have a business strategy in place, you put together a framework, not just for the business, but for security itself. Aligning the architecture, infrastructure, partners, applications, software, systems, and business planning that you've put together to a security framework like NIST, SWIFT, and many e-commerce structures, PCI, SOC, or ISO 27001, you can create an architecture that matches that framework when it comes time to designing the system that you're going to perform. Good example of this is when you're actually going into the design phase of creating an e-commerce or data site. You're going to build and design components based off of vendor best practices. But by aligning them to the frameworks and security standards that you're actually following, you can also question, am I using applications that are secure? Are those companies that provide those applications aligned to the same security frameworks that I am? And by doing that, I'm able to identify in my framework how they fit into that framework. If they don't, I need to mitigate those by putting together security components that protect that application or that vendor or that third-party system through my own framework. Then when you move from the design phase and you've solidified how you want that design to look and you're starting to implement it, you can also build those security controls into the project and product development that goes into implementing the service. By doing this, you're ensuring that if there are tweaks or changes that need to be done to the design because of building the actual software, you can make sure that the security components and the policies that you've identified back in your strategy and framework are still being upheld as the project goes. This means that testing can be done throughout each of the milestones in the project by security people or by the project team to see that the testing shows that things are still secure as they're being implemented. This is important because when most implementations are being done, systems are broken down to their simplest forms, meaning that as they're being deployed, root is used to deploy software. Administrative access is used quite fluently for all the people that are actually deploying the code, creating databases, compiling, or developing software. This has to be monitored throughout that whole period. And by monitoring it through that whole period, you're able to see that this is normal activity for a development environment. But when they're finished, how do we know that that's normal? That's how when you finish an implementation and hand it off to operational management, meaning you're now going to prepare to go live, you can make sure that what you aligned in the implementation phase to how you expect it to be after it's been implemented can be monitored. This means that things like root access, administrative access, or developers running code usually stop because now the systems have been compiled, they're ready to be activated, and you've tested what a user would normally be seeing of the system. Any activities after the management phase that show implementation-like activities, like root access or compiling code, can be tagged as suspicious. And by tagging it suspicious, you can implement the controls that are needed to say that during a normal life cycle of this application, this should only be happening during change management or through a product being developed. Anything that's found after this activity goes back to looking at the strategy, looking at the framework, looking at the design, and looking how the implementation was done to say this is not normal. So with looking at all those 5 steps and keeping into the line of frictionless commerce, we always have to ask ourselves when we're in the business strategy of how is a customer going to interact with the site? How do we secure it? How do we use partners and software vendors to create these sites? And how do we keep them secure? And what are the ways that we can automate and make it frictionless? Meaning make it easier for automated processes to be put in place, like APIs between systems, in a secure way that we no longer have to be concerned with it. And then we can move on to developing the faster, more robust sites that are out there. When building the framework, it's best to align with industry standards. There's industry standards out there for many different areas of security. When it comes to e-commerce, the more commonly known ones are the SOC compliancy for making sure that there's a framework in place for addressing financial controls and reporting. There's PCI DSS, which is specifically around how to do credit card transactions and processing. But there are security frameworks that have been in place for a long time around NIST, infrastructure framework, CIS standards for hardening systems and applications, and ISO 27001 that shows that you're monitoring and managing the services that are being offered in a very secure way. By combining these to match the industry that you're in, eCommerce and PCI, ISO 27001 for service providers, you can actually put together the controls list that are identified in those frameworks against your strategic plan to say that as we move from what the business is trying to develop into building a security framework that matches managing it and protecting it after the fact, you can always come back to the framework as a guide to record and monitor the specific applications or services that you're offering. When designing the service, now that you've identified the framework that you're going to follow, you're going to find that no matter where you're designing it, in the cloud, whether using a SaaS provider, on-prem, physical or virtual, container-based or databases, you're going to find that although there are many components that are being connected to each other, by aligning to the framework, you can always see and identify the controls and the boundaries between systems to protect those systems from each other and from the outside world. The importance of this starts to become very clear when you get into the cybersecurity frameworks around specific areas like identity and access management, endpoint protection, vulnerability and threat management, and the components that make up the specific service that you're offering. This becomes more apparent when you look at things like databases, web applications, middleware, access controls, firewalls, VPN access, identity and access management from a web interface. This becomes clear when you start aligning the framework questions that you ask around the different components that make up the design. Database servers have a specific way of accessing them, how they store the data, how they secure and encrypt the data, and how the data is accessed between database systems. Application servers have a specific way that they're accessed, the way they store their data, how their configuration is protected, as well as front-end systems that get a lot of activity, how users interact with them, and how they interact with middleware and middleware with database servers. All these interactions can be aligned to the frameworks. And by aligning to the frameworks, you'll always have an idea of creating an overlay on top of any design that's used, no matter where it is, to be able to see how it's protected, how it can be protected, and where you might see vulnerabilities if you were looking. This becomes more apparent in the outside systems more than the inside systems. Traditional design was always layered. There was the core, the edge, and the outside. The outside being the untrusted network, the inside being the trusted network, and the areas that customers needed to access were known as demilitarized zones. Now that we move to a SaaS-based or cloud-based service, we start noticing that the traditional design has changed. There are a lot more components involved now that we're in the cloud, but by being in the cloud native type environment, we're able to see a secure mechanism in the back end already in place, provided by the service providers, making it so that you're basically accessing a black box. But by accessing a black box, you still need to ask the questions related to the framework about how those providers supply the components that you can use for security. Whether it's using a cloud provider that allows you to pick any components you want, or a SaaS provider that give you an internal and external access, input and output basically, and a secure way to access their systems, they need to be able to supply you with the evidence that they've also secured those systems internally. By having a supplier that designed the system based off of a framework similar to the framework that you're aligning your product to, you can find that they've already asked themselves those questions. They've already aligned their design to those controls. And by showing you their report, without having to show all the design and aspect ratios of components connected to each other, you can trust that that provider has built a system robust enough to support your application support your services because they're following the same frameworks. So now that you've created a design and you're following a strategy and you've aligned to a framework for security, once you get into the project planning stage and start building your application, you're going to find that projects and product development don't usually follow the same rules that security does. This is because there's milestones. Milestones mean that certain aspects of the product and project have to be completed on time, under budget, and as quickly as possible in many cases. Hence Agile, Swift, and other frameworks that have come along to make it so that you can actually deploy something as quickly as possible. The key to being able to make it through the product and project phase is to make sure that you're still following your framework, that you're actually making sure that the milestones that are being created in your project plan have testing that include security testing, whether it's through scanning, doing a penetration test after a beta release, or actually checking developer code to see that it's being developed in a secure way. You can actually make it so that it becomes easier for the implementation team to continue to move quickly throughout the development phase. By following compliance and testing as if you are already in production, and ensuring things like the strategy and the framework and the design are still being met, meaning there hasn't been a deviation or a change to the design without going back to the design phase and checking to make sure it's secure again, and creating proper handoff documents that can actually be handed off from the architecture project teams to the operations teams when they're finished, to show that what was actually designed is actually what was implemented. This makes it so you can actually do a risk assessment and a compliancy check, as well as penetration testing and scans that you already did during the project phase as a final step before it goes into production, to show that the baseline that you had during that chaotic time when everyone was accessing the system as root is actually secure now and completed, and what lockdown mechanisms needed to be put in place for CIS hardening standards and any standard that you've built as part of your framework have been met. It's literally a checklist. Now that you're in the management phase and your handoff from development moving into production has started, it's time to establish the categories in which the framework was actually built and put together the automations and the alerting and the orchestration that you can do to make sure that the systems are always being monitored. This means you can break down the frameworks as they were designed into the categories that made up those controls, like identity and access management, endpoint protection, threat intelligence, and the typical governance and risk and compliance frameworks, and how they're collected every time an audit is done. By putting this documentation together and putting together the mechanisms to measure them, whether you do it automated or manual, means that you can make it so that it's smooth. Once a year, once a quarter, whatever the compliance requirement is, to actually check the evidence that you're still following the procedures and the systems are still being protected in the right way, become easier when you start putting together the framework in a way that can be workflowed, automated, and communicated on a regular basis. Meaning if you can make it so that you can look at any time to see that identity and access management is being done the same way, passwords and their complexities, multi-factor or adaptive multi-factor authentication, all those systems being put in place in a specific way so that they can't be modified, or if they can be modified, they're done in a secure way, means that all you're doing is checks. And by putting checks in place, you can actually have a look into only the things that have changed. And by looking into only the things that have changed, you'll find where most of the vulnerabilities are. A good example is, as vendors develop applications, the version that was used to deploy the application, there will be vulnerabilities. And the vendors that actually create the software will actually release those vulnerabilities as part of their patch release. By always having patching and vulnerability scans being done on a regular basis in your system, you will find those vulnerabilities before or at the same time that they've released them. And the plan for patching them or updating the software can be scheduled quite quickly. Good example is critical threats being found can be patched within 3 to 5 days, or even sooner if you have an automated system that does it for you. If there's going to be impact to those systems, the impacts have been pre-recorded based off of the design and the implementation that was actually created. This is through documenting the impacts and the effects one system have on the other. Communicating these metrics through automation and creating a reporting mechanism to be able to show it at any time during a regular audit period means you could potentially make it a live dashboard of anything and everything that's happening at any time. So ultimately, by combining the components from strategy all the way through to management, and then identifying through management the changes that happen throughout the product life, a life cycle control can be put in place that says that anything new or any new developments, by following the same life cycle control of going from strategy all the way through framework, design, implementation, and management, and following that cycle over and over again with the controls in place to check always, will make it so that any vulnerability or any risk can be caught early. And by putting them into an automated or orchestrated way, you can actually make it frictionless. You can make it easier for the business to just continue while security is watching over. And by having security watching over, they can identify risks well in advance and not only become reactive as the typical security compliance is today, but get into a protective and, better yet, a predictive way of being able to identify threats before they happen, threats that are happening elsewhere, and put the protection mechanisms in place automatically for the product that you have to protect you based off of what you're seeing in their industry. Good example being, there could be a release tomorrow of a threat that hit a specific company that we see the news of. By getting the threat intelligence, meaning how the threat actually was found, what were the steps that went into the threat being actioned in that application, system, or company, reverse engineering it and supplying that information to the rest of the industry, we're able to give the blueprints on how to protect anything that happens at any time. By doing that and sharing that information, we create a frictionless way that any e-commerce site can protect the other. And by creating enough of this sharing of threat intelligence, we can actually protect the rest of the industries out there as well. Again, this is a pipe dream. This is something that needs to be done. This is something that the industry's been waiting for a long time. But by creating a frictionless way for communication and trust, we can drive better business, frictionless business, through the data and the security of that data. I want to thank you for having me, for listening to this recording, and for enjoying the conference. If you have any questions, reach out to your coordinators, and they'll put you in touch. And I'll be glad to answer any questions that you have.